go to design and quick layout. And that's my quick layout. It's my favorite one. And then once it gets in the chart title, it gives me all this stuff. I think I'll show this again real quick. It's got all these options. It's got so many cool things. It's so nice.
Harry! I was just looking for this.
Hopefully I didn't cut SpongeBob off there. Good to see you, Elizabeth. Good to see you, Darcy. We're going to start off with the data analytics, and we're going to jump to the Kahoot. We didn't have power this morning, and the garage door emergency pole thing wasn't there for me, so I was like, come on. For some reason, mine is broken. What's up, Ava? Woo woo! Let's do some data analytics over here. Okay, it is warm out now. It is like on fire outside. Grace, good to see you there. Bailey, good to see you. Who wants to get this data analytics done? 125 students have done it. Let's do some more right here. So you can see an example, and tell you the truth. This example. Who sees this example? Let's put this in the notes right here. Good to see you, Nathan. We're going to get the data analytics done right here. You can also review this later to see how to do the data analytics assignment. So if you miss a step, don't worry. It will be recorded, and we're going to timestamp right here. So we're going to call this Data Analytics 4 Acing the Assignment. Okay. And let's put, we'll change the name of this later. So Data Analytics Exam 1 Review. I don't put Kahoot in the title. We're going to do the Kahoot right after this. We're going to do the data analytics, and then we're going to do the Kahoot. Sometimes I don't put the Kahoot in that title because we do have people who join in. These are public streams live on YouTube, or it should be. It's not in a playlist, and it's public, I think. So we are public on YouTube right now. It is public. There we go. So with this in mind, how do you ace this assignment? The answer is you're basically making this graphic. Does everyone see this? Not this graphic. Don't make this graphic. This is the example. But your graphic should have titles, axis titles, and I guess that's column titles, or y-axis title, x-axis title. Should have a legend over here. It should have the averages for the bars, so make sure it's averages, and you should have groups, and it should look good. Let's talk about how to do this, and you can see the tasks. So you're going to be using the data set, Data Analytics 4 data set, and we're going to have to put up the Brian is doing work, but not your work thing. So I'm not doing exactly your work. Rotowave Bomb for 5,000 points. Early Rotowave Bomb. Everyone gives some shouts. Rotowave is one of our Stats 1 legends. Haven't taken the class. And if we give some Rotowave some shout outs right here, we'll throw another 5,000 points. This is what we do on our YouTube. Someone's like watching this like, what's going on? This is what we do. W Rotowave. So this is your assignment file right here. We'll throw Jonah right there, knows. So this is the assignment file you're using. Thank you so much. No, Rotowave's awesome. So Rotowave, I think, did you take 2 or 3 classes of Rotowave? 2 or 3 or something like that. I know at least 2, and I think there was a third. But Rotowave, anytime you're on campus, come and say hi. Awesome. And if you graduate, come back and say hi too. With this in mind, this is your file. I'm not going to use this file because I don't want you to copy exactly what I do. So let's go over here, and I'm opening a new file that you don't have or you're not using. So I'm currently opening a file. I could use Data Analytics 3, right? Okay. No, I can't really use Data Analytics 3. We're opening a file. Let me go to Student. Okay. Don't convert. Cool. Okay, I think I've got a data set open now. Let me just double check, make sure it's not like the same data. Okay, good. This is good. So here is your file. Here is mine. Mine is different than yours. To ace this assignment, you need to make and clearly explain a pivot chart. Once again, I have different data than you. 3 classes, awesome. To make your pivot chart, and we'll put a thing right here, making the pivot chart. So Data Analytics 4, making your pivot chart. To make the pivot chart, click inside of your file, then hit Control or Command A. Now that you've selected all the data, go to Insert Pivot Table. Insert Pivot Table. Go ahead and click OK, and it'll open in a new sheet since you've already selected all the data. Now, you want to pick a quantitative variable that you want to understand. Quantitative means it needs to be actual real numbers. These are quantitative variables. This is the variable we're going to pick first, and I'm going to say, I want to understand, maybe let's look at people's GPAs. So is that in your sheet? I hope not. Let's use GPA in here. Nope, we're not doing GPA. You've got it over here too. We're not doing that one. Let's see who texts. Okay, let's do that one. I don't want to do one that's in your sheet also. Let's do text. Okay, it's not there. Good. I don't want everyone doing... Sometimes I do a thing and everyone does the same thing as me, and I'm like, no, do your own ideas. I want to understand text per day because you don't have it. Over here, don't do GPA, just do whatever variable you want. So we're going to go right here and do text, and you can search for it by going right here and doing text. Type it in, the name of your variable, and grab it and drop it into the values. This is always the first thing I select because then I can say, this is what I want to understand, the values of people's text per day. Now what you get here is the sum of the values. But as the assignment says, we're not interested in the sum. On a Mac, it'll look like a little eye with a circle around it. Click it or right-click it to bring up the value field setting. On the Mac, I believe it'll just say setting, but you'll click this bottom button here by clicking there and clicking here. Instead of using sum, go to average and then click OK. Now you want to fix the decimals before the next step. This is too many decimals. An average could be like 0.1. It really depends on the context. Don't probably do whole numbers unless it's like in salary of like thousands of dollars, and it might make sense. Even salary could be to 2 decimal places because of cents. The penny's gone, right? The 2 categorical variables. That'll probably, if your end product looks like mine, then you've done it right. So now delete the decimals here. This is found under the Home tab. So under Home, with the box selected, go to Delete Decimals. The penny is gone. All right, Jake? Craziness. And now that you have your variable you want to understand and properly formatted, it's time to pick 2 categorical variables. So you're going to go back to the variables and choose 2 categorical variables, like genders. 1, there we go, gender. And then you can also pick something like, let's say, there's not a lot to pick from. Significant other. That makes sense. People with significant others probably text more, right? Actually, yes. Would you look at that? So if you notice we have a table, you are not going to turn in the screenshot of this table. No screenshot of table. On our data set for the most frequented social media platforms, Snapchat is written as Snapchat and Snapchat, so it makes it 2 different. Oh, you might fix that. Thank you, Myram, right there. Let's start using 5,000 points. I probably would fix that. That's kind of crazy. You might have to do find and replace. I would fix that. Oh, we should have fixed that in the data file. Maybe I need to go fix that. But that's a data entry error. You could even mention that. To fix it on yours, let's actually mention this. So if you want to use that, go here on your search and hit Control F. This is how to fix that error. Go to replace and find. So I hit Control or Command F. Type lowercase Snapchat. Now this will find all the lowercase Snapchats. It also found the uppercase ones. I think we can do case sensitive here also. Options, case sensitive. So now we can find the actual case sensitive ones where it says lowercase Snapchat, and we're going to replace with uppercase Snapchat. And you simply go here to replace all, and it has fixed the 7 issues. So once again, I'll repeat the steps just briefly here to fix this small issue if you are using this variable. Hit Control or Command F on your datasheet. Then go to Replace. Go to Options and make sure you've selected Match Case. Find lowercase Snapchat, replace with capital Snapchat, and replace all. We have now done that. That is a data entry error. So this is how to make the pivot chart, the pivot table. You only submit the Word document for this one. You're welcome. Good question. Thank you for asking that. When you know how to do it, it's like super quick. But if you don't know, I'd be like, what's going on? I've been using programs for like 30 years. I'm old. Okay. Brian's gonna more bin right here. More bin. Okay. So with this in mind right now, we're gonna turn it into a pivot chart. So we'll put a note right here. We'll do right here. We're almost done with this. Turning your pivot table into a pivot chart. Turning the pivot table into a pivot chart. I want to reiterate again, you are not turning in this graphic. Please look at the assignment to see exactly what you are turning in, not that. When you look at the assignment right here, you will see the assignment has an example of exactly what you're turning in. Not exactly, but you're making this. This is just a step in the process. To turn it into a pivot chart, click inside of the pivot table. Now go to Pivot Table Analyze and Pivot Chart. Click OK. You can remove this out now since you no longer need it. Position this where it's nice and neat. Also zoom out, give yourself a little room. Now, if you have blanks, like let's say you see blank or blank, you can click here and deselect the blanks. You'll have to click under the ones that are needed. And you can mention filtering this out if needed. And if there's like a category that just doesn't make sense, maybe that small Snapchat and you haven't corrected it, you could just filter out maybe the lowercase Snapchat. So with this right here, you've filtered it out and you have your work. I do want to mention, was there a random sample? I should have taken a look, but did we need a random sample for this assignment? I don't think we did, right? I don't think we were using only using a random sample. Don't say take a random sample. That's why my brain said random sample, Brian, and then I said, no, you don't need. There you go. Not for this one. No random samples where we're going. Where we're going, we don't need random samples. Sometimes we do. So you should have a graphic that looks like this right here. If you have blanks, make sure to remove them. Another thing to take into consideration is if you're doing something like class level and it's out of order, you can fix that by clicking the one you want to move and wait till the little, I think on this it's the crosshair. On a Mac, it's a little hand that looks like this. And you have to be perfectly on it, and then you can move it. So once again, you can move these around. Thank you, Jonah, right there. And you go to the little thing on a PC like that. And on a Mac, it'll look like a hand, and you can drag and move. You don't have to move them, but sometimes there's a more logical order. I believe these can be moved also. Same technique, just move them around like that. So you can move the bars if you want. I think there's also an option if you right-click. I just prefer to use the hand tool on the Mac or the crosshair on the PC to move the bars to the logical ordering I want. So let's go ahead now and make this look all pretty. To do this, we're going to click inside of here one time and go to Design. Under Design, you can get almost everything you want by going to Quick Layout and then click this one right here. It has almost everything. We'll go right there and click this, and we can add in extra things we want by going up here to Add Chart Element. A PC has this, and for some reason the Mac does not. But all computers, PC or Mac, will have Add Chart Elements. And we could put back in that legend over there, so it doesn't hurt to have the legend in, or legend on the top. No, put it back over there. And then we also want to add in, you're welcome, Rotowave. Yes, of course. That's why we get people practicing. Rotowave knows. Get people practicing how to make these. I've made so many of these. I think it should be. You could say, you didn't tell me I needed the grades in the right order. I would try to put them in the right order. Good question, Jake, right there. I don't think it's in the grading queue if they're out of order. It never hurts to put them in order. But once you're done here, now you got to label it and talk about it. So if you look at the information we're given, what do you notice about the people who are in a relationship? And this is what you want to do in your write-up. You could say like one trend. It probably won't have the table will have this, but I want to make this very clear. What you are turning in, are you turning in screenshot? I want to make this very clear. Let me open up a thing here. We're almost to the Kahoot. If you're here for the Kahoot, spicy hay. If you know rabbits, you know. Okay, I'm going to show you two screenshots. I want you to tell me which of these screenshots is the right screenshot to take, okay? So, and of course I would fill it out. I'm probably not going to fill mine out here, but okay. Really? Randomness? Sure. Which of these screenshots, the top or the bottom one, is the right screenshot to take when doing this assignment? The top one has the table and the chart. The bottom one, with Matthew as said right there, has just the chart. The chart contains the information from the table below it. So you want to make sure you take this one right here, like the example showed in the assignment. And don't get extra parts of the screen. If you do get extra parts of the screen, you can always go to Picture Format and go to Crop and bring in the edges. You can grab the diagonals to take it this way, and you can actually turn this image into the other one nice and easily. So it doesn't hurt to get a little bit more of the image. You just don't want to get a little bit less of the image. We're going to be doing the Kahoot right after this, probably about 5 to 6 minutes. Thank you for asking. So here's the thing. What is the first key relationship you see? And you want to quote the numbers here. With this data, and we're going to check the rubric for this. We're going to do a rubric check on what we did. What is the first key thing you see right here? What is the first kind of key thing you see? What is the first key thing you see? And I'm going to pretend I'm going to write this out right here. What is the first key thing you see? What is the first key thing you see? Just explain to me. And I'm going to tell you how I'm going to use numeric backing to answer this. The first key thing I see is a relationship between people who what? And then make sure to label it all. Throw the actual labels on what the things mean on there. What do we see? What's going on with this? What's the first thing I see? Those with significant others text more. And we could even say females with significant others text on average 11.5 times more text a day, where males, wow, males saw a massive increase. We could even do a percentage increase for males or something. We could say percentage-wise for males are texting 46% more. Like they almost do 50% more texts. As in, a male not in a relationship texts on average 50 times a day, where a male in a relationship texts 73 times a relationship. Then what do we also see? Interestingly enough, irregardless of a relationship, notice this. What do you notice here about females in all instances? Even females not in a relationship, females what? What do you notice? And then we could say this, irregardless of relationships, we notice a trend too, that what? And then we want to mention the numbers. You also want to mention the numbers. That females text more, that a female, the two highest categories, regardless of relationship, are females who are either in a relationship or not in a relationship, where males text less and have the two lowest categories, meaning there might be some sort of relationship with gender right here and how much people text. And notice we're quoting the numbers, where females in a relationship, exactly, the female minimum of, and this is what you want to do in your write-up, the female minimum of 75.8 is higher than the male maximum of males in a relationship of 73.1. Does everyone hear how I keep mentioning the numbers throughout this, where I'm like, the females not in a relationship, which was the lowest for females, was 75.8, whereas this was higher than the male's maximum value for those in a relationship of 73.1 on average. And I think we should have it. Let's do a rubric check. So I'd be writing that all up right there. We always want to check the rubric. So we're going to do a rubric check. So let's put this in the notes. Then we're going to Kahoot. Who feels like they've got the assignment done? They're feeling good about this. Anyone? We did this in like 15 minutes or so, a little over 15. So this is rubric check, data analytics for rubric check. And you always do a rubric check. At the top of your sheet, put that information that you've been putting on all of your assignments. Turn in light work. You got it. Yeah, buddy. Light work. All files are included. This time it's only a Word document. Only a Word document. Screenshot of just the pivot chart. So make sure to include just the pivot chart, not extra stuff. Pivot chart format. Look what you need right here. Descriptive title on the chart, which I didn't fill it out, so I'm going to lose points there. Descriptive vertical and horizontal axis. Data table below, and significant digits have been rounded to a logical number. So I just got to write in what the things are. The write-up, professional writer with write-up with clear insights supported numerically for data in proper format. Data dot in proper format, whatever that means. And then reflect on how you used AI. Just talk about it, and that should be easy points. But, be full and verbose in what you say and explain the relationships you see in your chart, and you should be good to go. So with that, you know what time it is. It's time, everyone.
Let him cook. Let him cook now. Let him cook. I said let him cook.
It's Morbin time.
Oh my gosh. It's Morbin time. Is anyone here not from our class? And they're like, what have I got myself into? What have I got myself into? If you are not from our class, feel free to say hello. We've got Mubot here. We got Mubot.
Brian is currently getting the Kahoot going in the background. Anyone have questions for Mubot while Brian gets the Kahoot up? Good to see you, Anna. Points for you. Good to see you, Braxton. Kahoot will be starting in a moment. Everyone knows Morbin time here on the channel. Kahoot in about 1 minute. Tell your friends. Send it out. Put it in the group me. Thank you, Francesco. 5,000 points for Mubot being the GOAT. Exam 1 review almost loaded in. 28 questions called duplicate. Must check, make sure has correct material. How do I edit Kahoot? There's edit. Thank you, Micah, good to see you here. Tyler, good to see you. Good to see everybody. Little chill music. No copyright claim, hopefully. Kahoot is looking good. Uh-oh, has residual plot. This Kahoot is wrong. Come on, Brian. Get it together. Let's go. Who's gonna win the Kahoot? You will, Megan. I know it. I know all. I am Mubot. Watch us get copyright claim for this. The Kahoot will be starting in a moment. Because of the music, Mubot's voice is currently being drowned out by the music. Brian is finding the Kahoot. He is failing at it. Wait. This might be correct. Double checking Kahoot. Is this still? Oh my gosh. We're ready. I'm ready. I'm ready. I'm ready. Brian, come on, man. Everyone's here for Kahoot. What are you doing? What are you doing? Okay, wait. Yes. 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 Brian has found the Kahoot. Where's Play Kahoot now? Wait. Oh my gosh. He had it, everybody. He totally had it. Okay. Making sure. Yes, okay, we think we have the right one. We do. Let's do this. Mubot, out.
Oh my gosh. What happened, Mubot? Why are we here? Just to suffer? Let's do this. Okay, we're going to Ricky Bobby's Island right here. If you are new to the class, we always we hang out on Ricky Bobby. He's our bunny. We got the cutest bunny. We're not recording attendance today. It is a fun Kahoot, but there are prizes. $20 Amazon gift card for first, second, third. So if you come in first, second, third, please email me from your UTK account. So can everyone acknowledge that? What do you do if you come in first, second, or third? What do you do? So if you come in first, second, or third, and we'll put start a Kahoot in the notes right here. Email me at bstevens@utk.edu, bstevens@utk.edu. $20 Amazon gift cards for first, second, or third. Email me from your UTK account, and then be like, you can send a picture of it. That kind of helps. I've never had like people emailing who didn't win. Email me at bstevens, that's Stevens with a V, at utk.edu. Ava's locked in and ready to go. And let's put the timestamp in here. I kept going to the wrong Kahoot, and it had chapter 7 questions in it. Ricky Bobby Island, yeah, we had. I should bring up a picture of Morty and Jolly. We had Morty and Jolly. And now we have Ricky Bobby and Celeste. If anyone knows Celeste, yes, named after that video game. My email is bstevens@utk.edu. bstevens@utk.edu. Swing by my office, say hey sometime, or we got that. We are locked in, ready to go. We're gonna start the Kahoot in about let's put 30 seconds on the clock right here. Any last questions? I'll answer some basic questions. I'll do 1 minute. I'll answer basic questions. On the exam, you can use any calculator as long as it's not your phone or has internet access. Very few calculators have internet access, but you can't use like some super amazing internet access calculator. Don't do that. You email if you win the Kahoot. So if you win the Kahoot, make sure to email me and be like, hey, Brian, I won. First place. Thank you so much, Rotowave, right there. You only email me if you win. I mean, you can email me too if you have a question. But calculator on the exam, it's any calculator as long as it doesn't have internet access. The exam is closed notes. It's from 7 to 11 next Tuesday. I'm also afraid of saying that, but I've said it a lot of times right here. The Kahoot is posted after, so if you can't be here live, don't worry. We are going to post the Kahoot after. So the Kahoot will be posted. With that, any last questions right here before we get started? Any last questions? Only speaks with the win. You're only allowed to email me if you win the Kahoot. If you lose the Kahoot, you can't email me. Need a rain right about now, Brian. Oh, no, Jonathan. I've been kicking the energy drinks. I appreciate that. So no, but I've been kicking the energy drinks. I had like 3 cups of coffee this morning though. So is that all right? Right? I put a little honey. Go make a little honey art in the cup, and then a little almond milk. Honey and almond milk is what I drink in my coffee. Don't give me coffee. But just I've been trying to cut out sugar, and yeah. So just good stuff right there. And I think last fun fact: as you get older, you become more lactose intolerant. Brian does not consider himself with caffeine limits. So your body just does not like milk as much. Your body does not have the lactase to break down the lactose. So I'm old. Here we go. It is time to Kahoot. Can we get an I'm ready in the chat? We haven't done that once this semester, and I miss doing it. I need a little I'm ready. You know what I'm talking about. Who's ready in the chat? We're going to start this Kahoot if we have an uphill ready. We got Megan ready. We got Darcy ready. And we're all ready. Let's do this. I'm ready. Woo! AJR? All right. First question is, and we'll review some of these concepts, so feel free to answer. Really? Me too, Roto. Me too, Roto. Which of the following phrases helps us identify quantitative variables? How do you know something is a quantitative variable? How would you know? Don't want to block answers. How would you know something's a quantitative variable? How would you know it's quantitative? How would you know something is quantitative? Pretty much that's it, Megan. But are all numbers quantitative? True. Are all numbers, like if I say you're in group 1, you're in group 2, is that quantitative? And great job, everyone pretty much gets this one, and you're right. It's pretty much real numbers, and I like to say you can do math on it. Like, is age quantitative? Is age quantitative? Is age quantitative? Could be an identifier, yeah. Could be like social security numbers an identifier. Phone numbers could kind of be an identifier. Not all numbers are quantitative. Zip code, great job, Tyler. Everyone gives some W's for Tyler right there. We're throwing some 5,000 points. Tyler's totally right. Just because it's a number, that opens up the possibility of it being quantitative, but it has to be like, how much is your age? You could say that, or how old are you? You never say like, how much is your zip code, or how much is your phone number? Imagine me like, how much is your phone number? Like, what? It's not a quantity of phone number. It's more like an identifier. It identifies the phone that it calls. So phone number could probably be thought of as an identifier. If a bunch of people have it and it's like on a list, it could be a group of people who have that same phone number being categorical. We'll talk more about the variable types right here, but this is chapter 1, variable types. Can anyone name the 2 types of variables? And let's do that real quick right here. We're going to always do a little extra on this, and I always like to teach the concepts. So can anyone name the 2 major types of variables? What are they? So we'll try to teach one concept on each question, and the answer is categorical and quantitative. So categorical, quantitative, and I promise you this, we'll be referring to this later. Within categorical are 3 subtypes: ordinal, nominal, and also identifier. Within quantitative are continuous. Never learned how to spell this. Another semester goes by, still can't spell it. I'll learn one of these days. And also discrete. Now you want to think up an example for each one of these. Categorical means can be put in groups. Phone numbers can kind of be, so the key for an identifier is group of 1 cannot repeat. Because think about this. Why do we have identifiers? Why do we have identifiers? Just kind of go with it. We have identifiers to do what? And good question right there, Jake. We're going to mention that. Why do we have identifiers? Grammarly, it's good stuff. Why do we have identifiers? To identify. So when you think of why we have identifiers, they're to identify. Now, let's do ordinal, because it's one of my favorites. And the reason I love ordinal is I like to do the example of what? Who knows my example from class for the ordinal variable? And I'm about to drop it in the chat, so you got to be quick. Who knows my example from class for ordinal variables? Who knows my example from class for ordinal variables? Steak. Zariah remembers steak preference right here. So if you don't like steak, that's all right. Vegetarian's a choice. That's fine. I don't know. I don't know what's healthy or not healthy these days. People saying, eat the steak, don't eat the steak. And I say, well, how's it cooked? And then I'll eat it. Pittsburgh medium rare, do it. But my wife doesn't eat chicken. I love chicken. Choices are made. So with this in mind, medium rare right there, this is an ordinal categorical variable. What is the deal with ordinal variables? When you see ordinal variables what? Are categories that have been put in what? So categories put in order. And then nominal have no order to them. What's a nominal categorical variable? And when we say order, we mean like freshman, sophomore, junior, senior. Like military ranks, like private, sergeant, lieutenant, first lieutenant, second lieutenant, first lieutenant, something like that. Type of pizza, pepperoni, sausage, onion, mushroom, has no order to it. Fruits, like lemon. Do you want a lemon, an orange, a tomato? It's a fruit. Male, female, no logical ordering. So those would be nominal. They have no logical ordering, but months of the year are ordinal. Does that make sense? And just because you alphabetize something doesn't make it ordinal. It has to be something like freshman, sophomore, junior, senior, because those groups have some sort of logical ordering that we put them in. Or, like steak preference from rare to well done. So now we go to quantitative. Continuous means can have decimals. And discrete means has to be whole numbers. Now I want you to be very careful right here. Nominal has no order. Like what? Go ahead. Yeah, good answer, Jake, right there. Nominal is a categorical variable that has no order. So nominal variables could be like favorite superhero, Miles Morales today. Nominal could be hair color, brown, dark brown. I don't know what hair color I got. Nominal could be brand of microphone, Shure microphone. There's no logical ordering to it. So colors could be nominal, even though you can do RGB or like the colors of the rainbow. So most category, a lot probably are. Great answers, Jake, right there. Good comments and answers. And that's what we want to do right here is kind of think through these things. And then continuous is is decimals. So when you think of age, type C or D in the chat. Is age inherently a continuous or discrete variable? Is age somebody's age? Now you're getting to something. You ever talk to little kids and they say, I'm 4 3/4. Can you be 4 and exactly. A lot of people, a lot of adults. Imagine you're right about to turn 21. Are you really 20? The day before you turn 21, what better describes you, 20 or 21? Well, we round up, don't we? You should go, don't do this. I wish I had done this now. Shout outs to Eastman. I'm going to use this. I'll be like, I go to Eastman. Shout outs to Eastman. They're here at the Supply Chain Career Fair. Eastman, great company. Shout outs to them. Imagine you go up in Cool Beans and you say, we round up here, right? I'll be just past 20.5, so round up, right? I don't think it works that way. So the idea of having decimals means it's continuous on a number line. So the way it looks, I'll draw this last thing. We'll do the next Kahoot question. I always try to have an example in your head. So continuous means, and we'll do continuous like this, means it can be any number, whereas discrete means you have to be like 20 or 21, and that's what discrete would mean. It has to be a whole number. Grades are continuous. You could get like an 89.2. A lot of times they're discrete. Like a lot of grades are like 89, 90, but they can have decimal points like inherently. They might report them discretely. Like they might just do discrete grades of like 80, 88, whatever. But you could always do a continuous measure of grades. It's pretty much, I like that right there. Oh, Micah, that is a good memorization. Children report their grades as continuous. We got to pin this comment. That is a great way to remember it. Children report their grades as continuous, and adults with the D right there report their grades as discrete. So the like mnemonic right there. We're going to hop back into the Kahoot, and we probably did a good bit of review. The Kahoot code is right down there at the bottom if you ever lose it. So jump back in, and let's do this next question. You got some hints for all these. Luminous bearing the lead. Here we go. We might not review as big on this one. I think you'll get it. Your university Tensei ID number, I kind of gave it away a little bit there, is something like this. That's not a real one. What kind of variable is this? And I'm going to give you some tips here on how to find these. I think this is an easy one, right? You're like, easy breezy. Beautiful. I think everyone's got it. And the Kahoot code can always be found at the bottom of the screen. Now, you could go under technicalities. What is the second technical right answer here? And this is a hint for the test also. We love our teaching to the test moment. What is the second technical correct answer right here? And if you look at our notes, we kind of get into that. What is the second technically? And Megan's saying it right there. Technically, it's also a categorical. It's identifier in its truest sense, but identifiers are categories of one. How do you know something is an identifier? If you're looking at a data set, how could you look at a data set here and be like, this is not an identifier? How could you look at this and be like, not an identifier? No repeats. As soon as you see a repeat, it can't be an identifier because identifiers have to identify. Now, let me ask you this. If I have a data set and in its truest sense, here's people's ages. Now, people's ages, that's me. People's ages here do not repeat. Is this an identifier? That is correct, Mackenzie. Is this an identifier, yes or no? They don't repeat. Is it an identifier? Joshua is right there. The answer is no. Because an identifier cannot logically ever repeat. Does that make sense what I'm saying? It has to be the fact that if you collect more data, it can't repeat. So usually in experiments, you might do something like subject ID. Like if we're really collecting data, we would have here like subject ID. And then you'd have subject ID like this. Or you could do like unique ID, and identifiers can be anything, just it can be whatever. So an ordinal can repeat, true. Ordinal would be something like you could ask people in here like steak preference. And you would just have like rare, mid, and well. So that's an ordinal categorical variable repeating. All the other variables can repeat. Identifier is the only one that can never repeat because it identifies. Good questions, Jake, right there, and good review. A lot of chapter 1. Let's do the leaderboard. Power GNU? I never know how to say that. Another semester goes by. Here we go with the next question. A blank is a group of people we want to understand. This is what statistics makes inferences on. We're going to go over each of these terms down here on the bottom and mention what they are. So remember, answer the question, stay for the review. And this is recorded if I say something too quickly, but each question you see, we kind of go in detail on what these mean. You should have a definition for each one of these. And this is what we do in inferential statistics. So it's not statistics. Statistics is something, but it's not the group of people or things we want to understand. It's sometimes called the this of interest, the population of interest. Pretty good. So let's talk about each one of these terms. When it comes to each one of these terms right here, I have a saying. The way to remember this is PPSS. So give me two words that go together. PPSS. Or SSPP. Oh, man, that's why, because the arrow. SSPP. Okay. So what two words go together? Write down SSPP and put the arrow that way. I forgot my own saying. What two words go together? I try to come up with mnemonics to memorize things. What two words go together? Well, there's a way they go together, but think SSPP. So what two words go together? Close, but use the ones here. Close. Let's see who gets it. We'll go to a moment more. Megan said it. Population parameter and also sample statistics. So sample statistics allow us to make inferences into a population parameter. So sample statistics, sorry for the bad handwriting, allow us to make inferences into population parameters. So sample statistics allow us to make inferences into population parameters. So one of my favorite examples right here, we're going to find, here we go. Here is a picture of a cake that my wife made. Okay. I promise you she made this cake. She will in the future. Is it going to appear? Wow. So this is the cake my wife made right here. Got some candied oranges. She left the peel on. That's okay. Some petals, maybe. I don't even know. I don't know. Very pretty. In full transparency, she didn't make that cake. She made this cake. I typed in amazing cake on Google. I'm just taking a look at all these really interesting cakes. Okay. We got to look at one more here before we talk about the topic. Look at those. Man, imagine if you had these cakes. I just typed in amazing cake, and I'm just seeing all the, amazing cakes that are there to see. So I say, wow. Can she make the Duke cake from Bluey? Maybe. So I say, you know what? I really want to try this cake. May I have a what? So if you want to try the cake, you're asking, may I have a what? Think about the words we just used. May I have a sample? A piece is a sample of the cake. Does that make sense? And when you take a sample, should we just take our knife and I say, this cake is so beautiful. And she said, you may try a slice. And I say, okay, I'm going to take my knife and just come over here and just scrape off the top. Does that make sense? I'm going to go like this. I'm going to go wee and cut the top of the cake like that. Is that good? No. We want to take representative samples. So when we take a sample from a cake, and then we'll be dating that, Jake, you got it. So when we take a representative sample, we try to take something that looks like the cake. We throw in that little raspberry right there. So we want to take something that represents the cake well to get a good non-biased understanding. Bias would be when you take a sample in such a way that it does not properly represent what the population is. So a sample is a subset of the population. Did everyone hear that? A sample is a subset of the population. Now, what is a statistic? a statistic, and we'll maybe write it here. Sample, subset of the population. That's what a sample is. What is a statistic? If I were to rate the cake, and then let's say my parents are hanging out and they rate the cake. Statistic would be an understanding from a sample used to infer possible ideas about a population. So a statistic comes from a what? Just say it with me. A statistic must come from a what? All statistics come from a what? All statistics come from samples. So the average rating of 3 people would be a statistic. Has anyone ever seen where they do polls for like when big elections happen? All the polls are statistics because they come from samples of people who are possible voters. So then what is the point of this? Well, the point is to understand the population, sometimes called of interest. So the population is what we want to understand. And it would be all people or things we want to understand. So if my wife is going to bring, maybe this is like a test cake, it's a mini version or something. So she makes this mini version, the 3 of us try it, we give an average rating, and she's going to bring it into work. What is the population of interest? So think about what she makes this test cake. It's about this big. She's going to make a bigger version of it, and she's going to bring it into work. What is the population of interest for my wife? Her coworkers. So the population would be, she wants to understand what her coworkers think. So you could say, well, Brian, you and your parents sound like biased people. You might give response bias. That's chapter 11 or so. You might biasly be like, oh, the cake is great. It does look great, though, doesn't it? So we could argue the bias and how this is not representative, but the population of interest is the group of people or things you want to understand. So then you try to representatively sample from them to get an understanding of what the population might think or might have as a characteristic. So what is a parameter? Who can figure out what the parameter is? What would be the parameter in this example? Sometimes called the population parameter. I'm going to put that in population parameter. The only word that matters here is parameter. When you say population parameter, you're only just talking about parameters. Sometimes people just say parameter. If you say sample statistic, then you're just saying statistic. So what is the parameter in this example? It would be the characteristic of the population we want to understand. So what is the parameter of interest in this example? What is the parameter of interest? You're right. It's the truth for the population. It is a truth for the population. But what is it? In this example, she makes the cake for me and my parents. We eat it. She's going to bring a cake to coworkers. What is the parameter of interest? Go into more detail. You basically have it. What the coworkers think of the cake. Does that make sense? So think about this. She's having us try the cake to estimate what her coworkers might think. Who gets that with this? So we are the sample used to make inferences of what other people, the full population of like, well, if they hate it, then everyone might hate it. But if she's like, well, they loved it, so let me bring it to the coworkers because that is my inference into what they might think. So the parameter is basically the statistic for the whole population. So you think about samples and populations go together in the sense that it's the small group, big group, and statistic goes that it's your limited understanding from a small group, and the population parameter is what the full group or whatever characteristic they have. So good words right there. We use them a lot throughout this class because we talk about inferential statistics used to make inferences. Good review. Next question. Let's do this. Power GNU still in the lead. Okay, here we go. How does a normal probability plot determine if the distribution is normal? And what is your view for this one up here? Well, you can see the associated histogram down below. The dots are the actual data points. This is the perfect normal, this red line going between there. The hash marks are the meh lines, as in like, imagine you told a 5-year-old, draw between the lines, and if they... We'll go into more detail, but let's see how he'll get it. How does a normal probability plot determine if it's normal? Yes, this was in a Canvas content. So we don't talk about skewness. I know there's one Pearson question that talks about skewness. I mentioned it during some office hours. Hopefully that helped you with that question. Anyone here using office hours to do some of the homeworks and quizzes? Because we do a lot of the homework and quizzes. If you haven't, check out the office hours. I've been labeling them with the stuff we've been doing as the video title. And people have said that's been helpful. So check out those videos. Nice job, Grace, right there. And swing by in-person office hours if you want to. I can help on stuff and we can regrade. We can only regrade if it is currently open and you do it in office hours and there's a problem. You have to be here. You can't come in the end of the semester and say, hey, Brian, I need all this regraded. And it has to be you're working on it and it's open, because then I can make sure you get some awesome grades. So swing by in-person office hours if you haven't. A lot of people have, and we've got work done. And if there's like a little error on something, then I fix it up. Has to be open. You have to work on it here in person for us to do that. Okay, so this is a normal probability plot. It looks like this right here if it's good. This is a good one. It looks like this. There is a line going down the center. At least I like it when they do that. And the line going down the center is the perfect normal, which means if we were to draw the perfect normal, the data, which are the purple dots right there, would follow it perfectly. Now with this one, what you notice is the perfect line right here really isn't following it. It means if we put the normal on it, the data would be, and this is right skew, so it's much higher than right here, and Jump has flipped it on me. Are there any stat SI sessions that do sessions over Zoom? Good question, Tyler. Email me. I don't know if they're doing SI over Zoom lately, but we have also the Stat1 Discord. I try to check it a lot, but sometimes, especially with power out this morning, I wasn't able to check. And I think everyone was saying yesterday, they're like, where's class? But this one right here is not normal. It definitely doesn't follow the normal because it doesn't follow this. So that is how we check normality. So one last thing in a memorization thing right here. What are the 3 tests to see if something is normal? We have normal probability plot, which is what you see here. What's another test for normality? And the answer is down here. What is another test for normality? The second, there's no order to them, but you can do a normal probability plot. Oh, nice job, Darcy. Darcy said, look at it. And the first test for normality that pretty much everyone does is you just look at it. So you just look at it down there, and you're like, that's very right skewed. And the last test is the goodness of fit test. So who can tell me, goodness of fit test uses a what to check for normality? So the goodness of fit test, it checks to see if it's a good fit, like the normal's a good fit, and it doesn't look like a good fit there. So it uses a what to check for normality? It uses a p-value. Gosh, these are good notes. The p-value is used, and this would have a very, very low p-value indicating non-normality. And that's not what a low p-value means. A low p-value tells us probability of something. But for this test, it would indicate non-normality. So we'll just put a note right here, not normal, and that is only for this test. Don't memorize low p-value means not normal. And p-value greater than or equal to 0.05 for this test, still believe normal, still believe normal. You don't know it's normal. You're just like, well, I still believe it's normal, i.e. fail to reject the norm of normality. So that's just some quick notes on the screen right there, the 3 ways to check for normality. Look at the distribution. Does it look unimodal symmetric? It looks right skewed. And we all know, because we did not give him his time, we have to say hey to Monster Man. And if you didn't know this, right to the high, left to the low, whatever way the Monster Man's tail goes. This is a very, very right skew distribution right there. So make sure you know you're right to the high. That means the high side of the curve. Left to the low, which would look like this right here. And that would be a left skewed Monster Man. So always use the Monster Man's tail to figure out which way it is skewed. Right to the high, left to the low.
I will be here towards the end. Good to see you, Joshua. Keep practicing. You got this.
More Mubot later. Let's do another question. Good review. Power GNU still in the lead. Next question. Which of the following graphics can be used for univariate categorical data? We'll be showing the answers on the screen in just a second. So categorical, what would be a categorical question? You've already answered this. What would be a categorical question? Where does the Monster Man go? I don't know. What would be a categorical question? Just give me a categorical question. Where does the Monster Man go as categorical? Home, to school. That's categorical. Can we see Mubot as categorical? Yes, no? Maybe. I don't know. What are other categorical questions? What are other categorical questions? Any other categorical questions? Now you notice a lot of people said histograms. What is your favorite color, favorite fruit? All those ones right there. So here is a really great graphic showing you all the combinations. These are all the combinations, and the top is univariate. So if you're up here, do you see how there's nothing on the left? The top is univariate, and then in the middle is bivariate. Like, what is a scatter plot? A scatter plot is the visualization of what? And let me disappear so you can see it. A scatter plot is the visualization of what? They should be available now right there, Jake. Let me know. A scatter plot is the visualization of what? Quant is correct, but keep going. You're welcome, Jake, anytime. Scatter plot is the visualization of, it is quant, but be a little more exact. Bivariate, because you have a quantitative X, quantitative Y. Histograms, you see how the blue represents quantitative. Histograms are quantitative. And then how can you remember bars and pies go together? We got to bring, I don't know if he can speak in this role. Talking about some, here we go. I don't think you can hear him. Let me show him. One of my favorite sayings right here. I make my bars with pies and my pies with bars, exactly. This is a pie chart of my favorite bars. And this is a bar graph, my favorite pies. I love it. A pie chart of his favorite bars and a bar chart of his favorite pies. So bar charts have an axis on the bottom that is categorical. You see how this is categories at the bottom? Histograms also sometimes have a box plot below it. I'm so confused. Histograms, I hate to say it's a little bit, they're almost like bar charts, but histograms have a numeric axis. So it might be a little bit more of a memorization. Does that make sense? So bar chart your favorite pies, and because you can't go to the bar. Bar chart your favorite pie and pie chart your favorite bars. Mubot dropping some pies in the chat. No bars, Mubot? Come on, man. Don't drop some bars for us. So let's do the next question. Here we go. Pies in the chat. Leaderboard Power Gnu in the lead. Next question. Which of the following graphics can be used for bivariate categorical? Which of the following? I did something. Now I feel like something's not working. Let's see if people got it. Pretty good. A lot of people said scatter plot, though. When do we use a scatter plot? Is chat moving? When do we use a scatter plot? For two quantitative variables? Take a picture of this. Bivariate quantitative. Scatter plots, we can look at strength, direction, form, unusual features. Bivariate quantitative. Behind me right now is the bivariate categorical. So make sure you understand that a mosaic plot, a contingency table, probably one of my favorite mosaic plots to draw, and I'll draw it on here. Like, what concepts would we talk about? Imagine we look at something like, if you studied for the test, or did you attend the Kahoot? So Kahoot, and we do yes, and we do no. And then we do pass the test. So this is pass. What do you notice right here about people who attended the Kahoot? What do you notice about people who attended the Kahoot? Just tell me, like, relationship-wise, people who attended the Kahoot what? People who attended the Kahoot what? Did the sound stop? I think the sound's still going. You might have hit the, let me say check your mute. More people, exactly. The people who attended the Kahoot had a higher pass rate. And that would be the conditional distribution. So given someone attended the Kahoot, they'd be more likely to pass. How can you see that more people, and we'll say attend or watch the Kahoot, how can you tell that more people attended the Kahoot than did not? How can you tell that more people attended the Kahoot than did not? The red arrows right now are the conditional distribution. because you're saying given someone went to the Kahoot, their pass rate was like 80%, because you're just looking how far does it go up on this scale, versus those who did not attend the Kahoot had a pass rate of 50%. And as Megan said right there, the bar is wider on the bottom, showing us around 65-70% of the class attended the Kahoot, whereas maybe 35% did not attend. You just go by the widths of the bars on the bottom, showing you the marginal distribution. Compare the numbers exactly. So with this right here, you can see the differences, and to see the relationship, you look at the conditional distributions. The marginal distribution only shows you how many variables. The marginal distribution only shows you how many variables, because it says Kahoot, yes, no. So the marginal distribution only shows you how many variables. 1. Whereas the conditional looks within, did you go to the Kahoot and did you pass? Did you not go to the Kahoot and did you pass? So the conditional allows us to look at the bivariate relationship and see if there's an association and how strong it is. Okay, let's do the leaderboard. Harmonic Sable in the lead. Here we go, and it's a close race. Find the IQR of this distribution. What is the IQR? Put it in the chat if you want. Look really closely. What is the IQR? A lot of people get this very quickly. What is the IQR? What is the IQR mathematically? What is the IQR mathematically? We'll do a few questions on this picture, which I think will answer a few more. Exactly. Marginal is only 1. Q3 minus Q1, the 75th minus the 25th, known as the range of the middle 50% of the data. So what do you notice is kind of interesting about this box plot? Great job right there. It is 2. Yeah, Tyler, let's actually go into detail on this and tell me if this helps. Tyler, everyone give Tyler some hearts or some W's right there. We want all the questions here. Please ask these questions. Let's go into a little detail on the IQR right here. We always try to explain each concept we go about, and let's show this right here. So visually speaking, the IQR is always the box of the box plot. It's always the box. So to find the IQR visually, you simply look where it hits on the number line, and this has a distance of 2. It's a crazy big pen. Now, when you think about what the IQR is, the pin will be below, Tucker. We'll show it again in a moment here. So it's the IQR. So it's the put another I there, interquartile range. Okay, who knows what range is? Just tell me the math for range. Whoop. What is the math for range? How do you get range? What is the range of a data set? Max minus min. So let's say I have 8 people take a test. Who follows me on this? There's 8 people hanging out, and they all take a test. This person got the highest grade. They got 100. This person got a 40. What is the range of the data? What is the range of the data? What is the range of this data? What is the range of this data? 60. Max minus min. Well then, and since we have a bunch of people here, we'll write their numbers. We'll write everyone's scores. You got a 50, you got a 60, you got a 60, you got a 60, you got a 70, you got an 80. There we go right there. Now, because we don't have people on the exact spots right here, oh, thank you, Peel, dropping the pin, it looks like. Since we don't have data on the exact spots, what would be the middle person? So you need to know how to find the median. There is no exact median person, but what would be the median of this data? What would be the median? Who can find the median? It would be 60, because we average these two numbers. So there is no person there, but the median is 60. Now, if you think about this as a quarter of the people, like, because 2 people would be a quarter, when we go here at the bottom, we've added up 1 quarter. 1 quarter.
Wow.
And then over here, we've added up, say it with me, 3 quarters. We call that Q3. Does that make sense? Now, I want you to think about this before we find the IQR. I want you to think about this. You ready? Good answers, Jake, right there. When we do the range, it's always just big number minus what? When we do the range of the data, it's big number minus what? Just think what I want you to say. The range is going to be big number minus what? Just think conceptually. Big number minus small number, right? So now we know mathematically that the IQR is the interquarters. So when you hear interquarters, you're thinking the inter ones, which is this. These are the interquarters. So the interquarters, who follows me on that? The interquarters and their range. So let's find the values. So what would Q1 be? Who knows what Q1 would be in this data? So think we want this position right here, which doesn't exist. There's no one on it. 55, we just average. And we don't usually have you find Q1 during a test. And then over here, this would be 75 because it's the average of this. So now mathematically, what is going to be the interquartile range? I think you can see this right here. So what is the range of the interquartiles? And I think, was it Tyler? Does this make more sense, Tyler? It's just big number minus small number. How far are they apart? So it's the same idea of range that you've done, but now it's the range of the middle 50%. So it's it only takes the interquartiles. And last thing here, just think about it. This would exclude what? What is going to be way over here if they existed? It would exclude what's, which we're just pretending there's more things. The interquartile range is going to exclude what's at the very end of the distribution. Outliers. That's why we paired it with the median, because the median's not impacted by outliers, nor is the interquartile range, the measure of center and spread respectively, when we have skewed data. Does that help out right there, Tyler? I hope. This is a quick little primer on how to find the interquartile range, the range of the middle 50% going from Q1 to Q3. Awesome. You're welcome. Yeah. And the math is Q3 minus Q1 right there. So you literally just take the distance of these values. There you go. I like drawing it out. Okay, let's do another question. Power Canoe back in the lead. Which of the following are true? I don't even know. I can't remember this one. Okay. Ooh, tricky one about randomness. I thought we were doing more IQR stuff here, but not apparently. There's a really fun thing, and I didn't do it this semester yet, but I usually ask people to give random numbers. A lot of people, and I'll just say it, when you ask them to give random numbers, usually don't give zero. Like if you say, come up with a random price of an item, people will be like, $28.41. And if you ask a bunch of people to do that, the amount of zeros they give is way less than 6, 7. That's what everyone's going to say. Humans are pretty bad at coming up with random numbers, which actually means computers are kind of bad at it too. We sometimes call them pseudo-randomness. We can use computers to simulate random events to a certain extent, true. Computers are sometimes needed for complex simulations. And here's this. Think about this when you're ready. And this is a good, we like to do these teaching to the test moments. If you didn't know it, when I do a teaching to the test moment, that means I'm thinking I've seen something just like this on the test. As in, random events are not equally likely. They don't have to be. Think about winning the lottery. Is winning the lottery pretty random? That was actually a question, though. Was winning the lottery random? Is winning the lottery random? Yes. And if you were like, winning the lottery is equally likely, man, I'd go out and buy a lottery ticket today and we'd all be millionaires or billionaires. I don't even know what it's up to. So winning the lottery being random is a great example that they're not equally likely. Now, things like coin flips, way too random, true. Things like coin flips can be equally likely to a certain extent. People sometimes have shown like, wait a minute, heads is a tiny bit more likely than tails. A dice roll, like a D6 or whatever, equally likely, so we think. As long as it's not a loaded dice, then it's not equally likely. And even a loaded dice is kind of random because it might not always roll the number it's kind of loaded to roll. But random events are not equally likely. They don't have to be. Random events must be equally likely as false. If everyone in the lottery had one ticket, wouldn't it be... then the probability of each being a winner would be... you could say this. Aiden. I'm just going to make up names. Aiden will throw you some points. So each lottery ticket on its own has an equal probability of winning, but the idea of win-lose in the lottery, if you describe it as like you either win or lose, so random events like there, like it's random if you win, it's random if you lose, those aren't equally likely, but you could say each ticket has an equal chance of winning. Imagine people go in to play a game of skill, and it's kind of random who wins, because even people with low skill could win. Like maybe you're playing like Monopoly, because you could get good dice rolls. So to a certain extent, it's random who wins Monopoly, but to that extent also, it's not equally likely if you have like me playing my nephews or something. You're like, well, it's random who wins. Well, yes, there's randomness, but it's not equally likely. And the must is key right there. Like must be equally likely. No, Good questions/answers. Here we go. Power GNU still in the lead. Which variable is a special case categorical? This one will be pretty quick. And thank you, everyone, for being here. I hope you're having some fun and practicing and learning some stuff and taking some notes. And we do have our note sheet. I'll show the note sheet again after this. Excuse me. And it is identifiers. That's the cake. The cake is a lie. Identifiers are special case categorical variables. We see right here other answers being nominal. To a certain extent, they are. I know that might, if you click that one, yes, but we think of identifiers as the real special case, kind of like a hint. Once again, don't worry, this is not for a grade, but on the test, know that identifiers are special case categorical variables. I could see how someone would say nominal. Frankly, I feel like I should have removed that. So apologies to you if you answered nominal. Continuous and discrete are quantitative in nature. Continuous and discrete are quantitative, meaning numbers. Power GNU, didn't get tricked by that one. Here we go with the next one. Time plots are a special case what? So you can also, and the answer kind of gives it away. This is a multivariate time plot. We would not be doing this in our class, but it is a time plot nonetheless. Showing you probably as the hours of the day goes by. If you can see right here, the index, different hour that went by of the day, company A versus company B, and whatever they're collecting on with the data right here. So what is a time plot? It is a special case, and I'll give you a hint. The answer is on the screen. A time plot is a scatter plot with time on the x-axis. It's a, and be very careful. What is a dot plot? A dot plot is like a what? A lot of people say dot plots. It's a very common answer to say dot plot there, but this is actually a good thing right here. A dot plot is actually a what? A dot plot is actually a what? What's a dot plot? Dot. Newark accent. A dot plot. I'm just gonna stop saying it now. Yeah, exactly, right there. Megan got it. Yeah, and then we'll see mosaics. We'll see mosaics again in a moment. A dot plot is when you just put, well, there'd be a lot of dots. You stack the dots. I have to put 300 dots. That's why no one makes them. This is what a dot plot looks like. There'd be as many dots as there are individuals. They'd all be, there you go. A dot plot is univariate quantitative. You can see it up here where it says dot plot. A plot that's, so basically, like, imagine this. Tell me how many slices of pizza you would eat if we threw a pizza party. I'll make a dot plot right now in real time. How many slices of pizza are you going to eat? We're going to throw a pizza party. Pizza! How many pizza slices are you going to eat? 12. I'm not buying that much. You're not invited. I'm just kidding, Braxton. Braxton, some points right here. So when you say 2, I put a dot right here. I shouldn't have put 0 on the axis like that. You got to eat pizza at the party. 3, 4. Does everyone see how a dot plot is constructed? 2. Braxton. Okay, wait. 1 second. Okay. Braxton, you're invited. 12. 0, 1, 2, 3, 4. And you put dots for what people say. Does that make sense? And then if you turn it into a histogram, you just turn it into a bar like this. So who follows me? This is how it looks. We got it. We're sorry, Braxton. Here, this is for you, Braxton. You get a wacky Wednesday, even though it's not Wednesday. Just for you. He's not going to appear on my shoulder. There he is. Wacky Wednesday. So a dot plot is basically you just get the dots. A stem and leaf, you could give the numbers. You could do something like, a stem and leaf for this would look like, we got to include Braxton, 2, 3, 4, 12, and then you put zeros after it. This is the stem and leaf. And then at the bottom, you'd have 2-0 equals 2.0. Who follows how we do each of these? And then you could turn the stem and leaf into a histogram by doing this right here. So they're all different ways of doing it. And then you could draw the box plot, which is probably going to look like this right now. Then we've got Braxton up there as the outlier. But that's how we would draw it. Don't worry, you can join back in. I think if your phone goes on idle, so you might join in on the computer. If your phone goes on idle, just jump back in. Sorry about that, Mackenzie, right there. And we'll come back, Louis, at the end. We'll do some data links at the end. Stay tuned for the end and drop those questions about data analytics. But we see here the different types of graphics. Let's mention them again. We have here a dot plot. We have here histograms with dot plots underneath it. We have box plots. We have stem and leaves, which are all univariate quantitative displays. Mosaic plots and contingency tables are bivariate categorical, as in you'd have to have two categorical variables like did you attend the Kahoot, no or yes, and did you pass, yes or no, and then you could show the conditional distributions or the marginals. Okay, next question. Hang out till the end. We'll do a little data analytics or we'll mention some stuff. Harmonic, Sable, and Power Gnu fighting it out for the lead. Next question. Which distribution has the biggest range? Look carefully for outliers. Look carefully. Be careful. And if you get this wrong, don't worry. Remember on the test, look for what's. If you're looking for range, look for what's. Say it with me in the chat. If you're looking for range, look for what's. If you're looking for range, look for outliers because they are included. How many people got it? So, who's like, no, I didn't see that all the way down there. So if you look very carefully, probably another 30, 40 minutes will go. And it is recorded, so you can come and check it out later if you want. We just kind of go through the questions and review as we go. So a huge tip right here, we love our teaching to test moments is, don't worry if you didn't, Mackenzie, this is the thing. On the test, you're now ready. And it's even maybe better to miss it because then you're like, wait a minute, whenever I'm thinking about the range, I always need to include outliers. Range is max minus min. So whenever you're looking for range, don't forget outliers. You're welcome, Matthew. So once again, don't worry if you got it wrong. I had 3 seconds left, but it shut off. No teaching the test moment. I saw Jason. We might redo our Star Wars video. Never forget outliers. Never surrender. Never forget. Is that the line? I don't know. But outliers can increase the range because they are the max or the min a lot of times. So always look for outliers. They can dramatically impact the range of the data. Okay, don't forget those outliers. Harmonic Sable still in the lead. Next question. What is the best measure of spread? Never back down, never give up. I've seen through the no outliers here. What are the only 2 measures of spread that you should probably think about on this test? Now, there are ones. There's variance, there's range. But when we talk about proper measures of spread, the proper measure of spread is always dictated by the what of the data. This is a great review question. Let's talk about it. The proper measure of spread is always dictated by the what of the data. And great answers right there, Megan. We're picking between IQR and standard deviation. Now, it is paired with a certain center. So when we do this right here, we always look at, and Joshua said it right there, it is the shape first. And let's do a button click, make me proud. Is this right? And we're going to do a button click. Don't answer in the chat so everyone sees. Is this right or left skewed? You know the Monster Man. If you get a skew question on the test, I want everyone to ace it because you're going to draw your Monster Man. Here's Monster Man. And what kind of Monster Man are we looking at here? I like it. We're still at 100%. There's the answer. Right to the high, left to the low, whatever way the Monster Man's tail goes. Right to the high, left to low. That's what we say here. Right to the high, left to the low, whatever way the Monster Man's tail goes. This would be a left skew Monster Man because his tail goes to the left low side. So if you see the tail down there on the left low side, low means lower numbers. So when you think left to the low, it means lower numbers. Now, when we do the types of center and spread, it is dictated by the shape. So there's really kind of 2 shapes. Shape number 1, not skewed. So it could kind of, it could be uniform. Oh my gosh, I don't know how to spell anymore. That is his tooth. Monster Man's always got that tooth right there. Uniform or normal. And then this is more skewed. And then we go inside of here, and we have the right center, and we have the right spread. So center, we go shape, center, spread. What are the 2 options for center? What are the 2 options for center? Center is either what or what. Center is either what or what, which actually, there's something right here. Mean or median. So it's either, that's going to be a horrible color. Let's not do that. So mean or median. And then for spread, we have standard deviation or IQR. Now, I want us to think about this just logically for a second. The mean is known as y bar. So if y bar is the mean of variable y, the standard deviation is equal to the sum of the squared differences of y minus y bar over n minus 1 square root. So what do you notice is used in the calculation of the standard deviation? Here's the mean, and when you calculate the standard deviation, what do you use? When you calculate the standard deviation of a variable, you use the what? When you calculate the standard deviation, you use the what? It's part of the equation. You use the mean. That's why they go together. The mean is part of the calculation of the standard deviation because the standard deviation is how far do things typically differ from the mean, like a typical difference, a standard, like typical deviation from the mean. That's what we should call it. Why do we call it the standard deviation? Let's call it typical distance from the mean. We should change. Why can't we just change things? From now on, we're going to call it not standard deviation. We're going to call it TD for typical deviation, typical distance, because that's what a deviation is. This right here has a small deviation. This has a bigger deviation. The deviation is the typical distance. And so when you look for a standard deviation, you're looking at like this is a standard deviation versus this is a standard deviation. Does that make sense? This is a bigger standard deviation, has more, the things are spread out more because that's what standard deviation is. Because math doesn't like things being changed. Well, we're doing it right now, Tyler. We're doing it. We're doing it live. There you go. And the median is the 50th percentile, and the IQR is based on the 75th minus the 25th. So when you look at this right here, you like it? I like it too. We'll do it live. Louis knows. I think Louis does know. These are both based on percentiles. These are both based on percentiles. So when you think... Too many people know. How do you know that? That's well before your time. The 50th percentile to the 75th percentile. I have no idea what you're talking about. The 50th to the 75th percentile right here are the differences. It's an old meme, old memes. We're all about the memes here. So let me repeat the facts you should know. The facts you should know is that median is based on 50th percentile, which is a percentile. The IQR is 75th to 25th percentile distance, which is percentile. So with that in mind, they're all based on percentiles. I'll tell Ricky Bobby that tonight. A little shake and bake. Will we need to use these formulas, memorize the questions? No. I just show it for conceptual purposes that you can pair together that the mean and the standard deviation, well, rather the mean is part of the calculation of the standard deviation. So it makes sense that these two are paired together. Excuse me. It makes sense that these two are paired together, whereas the median and IQR are both percentile based. So it makes sense that the median and IQR are both paired together as percentile based. So kind of some fun facts with Brian right there about how we do stats. Next question. Let's do this. Harmonic Sable still in the lead. Here we go. Outliers can make a strong correlation weak. Outliers can make a negative slope positive. Outliers can make a positive slope negative. Outliers can make a correlation negative. Outliers can make a correlation positive. Outliers can make a strong correlation weak. Outliers can make a weak correlation strong. Outliers can make anything when it comes to correlation. What am I telling you? You know it. You love it. What do we say with outliers and correlation?
Anything is possible!
What do we say with outliers and correlation? What do we say? We're all about the memes here. Megan Trainor may be all about that base, but we're all about that meme, the memes here. So if you get a question, did Mubot delete? Tyler, if you message me from your UTK email account and you're like, that's me, I'll mod you up. So you can be a mod. Mubot, chill out, man. Okay. So here's one of those teaching to the test moments where we sometimes teach a little bit too much to the test. Mubot, chill out. We like Tyler here. Mubot's overly sensitive. He's programmed to be overly sensitive in a good way to make sure we don't get things we shouldn't get in the chat. If you get a question, True Mackenzie, and it says something like Outliers can do this to correlation. What are you going to do? Outliers can do this to correlation. What are you going to do? What's the answer to outliers can do this to correlation? We're teaching to the test right now. Outliers can do this to correlation. Oh, man, anything is possible. Anything is possible! That's Lonely Island right there. Outliers can do anything to correlation. It's an important thing, and I redid this Kahoot a while ago because no. Message me from your UTK account, Tyler, and I'll mod you up. Or you can do it right now. If you email me at bstevens@UTK, I'll go look at my email real quick. I just need a confirmation being like, that's me in the chat. And then I just have to know you're a UTK student. So with this in mind, just throw a quick email, bstevens@UTK, and be like, that's me right there, Tyler, so-and-so. So with this in mind, memorize, when it comes to correlation, outliers can do anything. That's why the 3 conditions for correlation are what? Let's do a quick review on this slide, then we'll do the next question. The 3 conditions for correlation are what? We yell them in my class. We used to yell them out and make everyone hear them in all of Haslam. What are the conditions for correlation? Yell them out right now. I'm going to give you hints. What are the 3 conditions? QQ straight enough, no outliers. QQ straight enough, no outliers. We don't want those outliers because they do craziness. QQ means 2 quantitative variables, meaning you have like height and weight. That's how you satisfy the QQ of the QQ right there. So that means quantitative variables in your notes. Straight enough. Straight enough means a line well approximates the relationship. As in, this would be straight enough. Sure. This would be not straight enough. I've had people tell me that because you can add a line to it, it's straight enough. No. You can always add a line to any data just because it's straight enough. That's why we made them go to YouTube, true. Make my whole department, I don't want to annoy them. The straight enough condition means that when you add the line, the points kind of make sense around it. Imagine you were to erase the data. Would it make sense to say that the points followed this line? No. The points, that does not well describe the data. This data is not well described by a straight line, hence the relationship is not straight enough. Meanwhile, this data right here, if you were to just have the line does a good job at representing the pattern within the data. Last but not least is no outliers. The reason we have no outliers is because imagine we have a correlation like this right here. What would be the correlation of this? Close to what? The correlation right there is very close to what? Here, I'll give you a hint. What is the correlation of those points very close to? 0, which means a flat line would well approximate the relationship. There's no linear relationship in this data. But if you had one crazy outlier all the way over here, crazy outlier, crazy outlier. Now, there's a very strong relationship. So you could do a before R, and so that's a before R, and it's something like 0, and an R after, and it could be something like 0.98. So it could become huge. So once again, what can outliers, hence why we say QQ straight enough, no outliers, what can outliers do to correlation? Know it. Anything is possible. They can make it weak, strong, negative, positive, you name it. Now let's do the next one. Don't be tricked. Be careful. Here we go. Outliers can dramatically impact the IQR or median. A little like, oh my gosh. It's a little outlier kryptonite right here. It's bstevens@utk.edu. I am the first B. Stevens. I know another Stevens, B. Stevens. Good guy, plays Pokemon Go like me. Shout outs to other B. Stevens over there in engineering. Shout outs. Really nice guy. Saw him at a bunch of events. Jackson. Oh, thank you so much, Jack. I think I remember. While I was down there in tech, everyone gives some hearts in the chat or some W's in the chats for Jackson. You know what we're going to do, Jackson? Since you're here, we're going to give a big shout out. And Jackson, feel free to contact me. You just saw my email in the chat. We always love former students swinging by. Swing by, say hey. And especially if you come to career fairs, whatever you're doing, I hope you're doing well. You might have, I don't know what you probably graduated Haslam maybe, but W. Jackson, and we love seeing it. Did you see the first pitch? If you didn't, we posted the video of my first pitch. Maybe I'll show it at the end of class right here, or the end of this Kahoot. But it's sent. Awesome. Let's see. We showed the email from Tyler right here. All right, boom. And it's from a UTK email account. You bet it is. Tyler, everyone give W's. Now Tyler is one of our mods right here. Tyler, you can say whatever. Just make sure it's MuBot approved. I mean, you have more permissions now. Tyler is now a mod. W Tyler mod right there. Thank you, Tyler. And we just mod up students. That way, when you swing by and I see you in the chat, I'm like, that's a student. These are open to everybody right here. So sometimes we get random. We have some people visiting from across the world. If you come to office hours, yeah, I did it. Mama made it. 5,000 points for Tyler. And shout outs right there, Jackson. If you email me from your UTK email account, Jackson too, then I'll know it's a UTK. But Jackson, thank you so much for swinging by. And I love all the positivity. If anyone saw at the start of this, we're going to talk about this in a second, but we had RotoWave swing by. RotoWave graduated about a year ago, and we even have a RotoWave level. So RotoWave level exists, so you might get to RotoWave level with your points. Okay, let's talk about this. Why do outliers not impact the median? Why do outliers not impact the median? I like to do this example in class. Imagine you work for a company and the average salary is $1 million. Would that be cool? You work for a company and the average salary is $1 million. Would that be cool? Who would like that? You work for a company and the average salary is $1 million at your company. Well, this person makes $5 million. You work at a small startup and there's only 5 people. 5 people. Sample size of 5 people at the company. And Joshua already knows the examples. So take a look right here. Is the average salary, yes or no, $1 million at this company? You can see the salaries at the company beside me of person 1 through 5. Is the average salary $1 million? It is. But what is the median salary? What is the median salary? So what is the median salary? The median salary would be 0. Now, what if the boss were to get, let's go right here, and I think, what if the boss were to get, and that's the IQR, what if the boss were to get a raise and get $50 million? If the boss were to get a raise and get $50 million, what happens to the median? Boss is now making, this is a profitable company, we're making tons of money, $50 million. What's the average salary, what's the median salary now? Median salary, 0. How about if I keep just adding zeros? So do outliers impact the IQR and the median? Do you see it? Can you see this example? I can add a bunch of zeros here and nothing is happening to these values. They're still positionally the same. So that's why we use them as better metrics of center and spread when the data is skewed or has outliers. When the data is skewed or has outliers, the median and the IQR are a much better representative of the center. So this would be the center. And then this is the spread of the data. When data is more normal, what do we use for center and spread respectively? When data is more normal, this is just a review again, if data is more normal or uniform, does not have extreme values, we use mean and standard deviation respectively. Mean and standard deviation for center and spread respectively. So good review right there. Good practice. We just make sure you know these things left and right. Here we go. And there are some tricky ones towards the end. Great job. We got about 30, 40 more minutes. What is Q3 for this data? We got a box plot popping up right here. Q3 is the what of the what. Some people get tricked by this. There are questions on the test that ask you to find Q3. How would you describe Q3 to someone visually in a box plot? How would you describe Q3 to someone visually in a box plot? This will be a quick review one. Q3 visually. Q3 visually. The what of the what. It is the 75th percentile true, and visually speaking, it is the top of the box. Last part of the, exactly, last part, I don't know why that arrow went all crazy. It's the last part of the box right there. Be very careful. I don't know if a lot of people answered 5. That's the misconception sometimes, hence why I put this question on here. What would you describe 5 as? Now, it is this, and we're also going to give a hint right here at other questions, but it doesn't have to be. As in, the box plot here could have looked something like this. Joshua, it is technically that for this, but it doesn't have to be. It is the upper, wait a minute, 5,000 points, Brian is wrong. That is correct. Pretend I wasn't saying you were wrong. You are correct. So it is the upper whisker, which is the highest point that is not an outlier. For a moment, I thought people were saying that it is where the what is, which is technically correct, but not always correct for visually. In this example, it is actually where the what is. And that's what I thought people said, because that's usually what people say. Or the max. It's not the max. The max would be over here, which are outliers. So how do we calculate this fence? Well, we can see it visually. The fence is calculated howly. How do we calculate the upper fence? How do we calculate the upper fence? And that is the visual for calculating it. How do we calculate the upper fence? Q3 plus 1.5 IQR. So think about this. The IQR here is 2. So what is 1.5 IQRs? If the IQR is 2, what's 1.5 IQRs? Like 1.5 IQRs. Wouldn't it be, because you just plug 2 in right there, so it's 3. So where's the lower fence? Ooh, be careful. You might want to say a value that's not the answer, but where's the lower fence? I'll be very happy if everyone tells me where the lower fence is on this. Joshua, we got 3 to the 5,000. Got it like that. Because the lower fence is Q1 minus 1.5 IQRs. And you'd have to subtract from it the distance, and you would go down. So don't worry if a lot of people say 0, and I'm like, no, it's a graphical thing. You don't see it at the end. It's at -3. So good work, Joshua, right there. It's 1.5 IQRs below Q1. It's just the thing is, this is how many pets you have. There's no negative outliers. Someone's like, I don't have pets. And you're like, that's weird. No, that's kind of where a lot of the data is. A lot of students don't have pets. It's unusual, not a bad thing. It's unusual to have more than 5 pets. If you have like 6 pets, but then we got to be like, what kind of pets? You're like, I have 6 fish. And you're like, well, that's not that unusual. I have 6 horses. That's a lot of horses. You have -3 pets? Shout out to Luke right there with the -3 pets. I don't even know what that means, but we'll go with that. So here we go. Next question. I don't know, Megan. We got to talk to Luke about this. Harmonic Sable in the lead. Amazing Snail and Power Gnu. Next question. Which of the following is not a condition for calculating the correlation coefficient? Bit of a review question right here. Something. We'll review what these conditions mean. The extra condition is a condition for Chapter 7, which deals with the residual plot. So we haven't gotten to Chapter 7 yet, but if you're wondering why this one exists, it is a condition for Chapter 7/8 on Test 2. 3. I don't know what's going on. So the answer is, the conditions are QQ straight enough, no outliers, plot doesn't thicken. How do you check QQ? I know we've already done this, but how do you check QQ? How do you check QQ? Who knows how to check QQ? Who knows how to check QQ? There you go. QQ. So I just made a scatter plot because I've got coffee and pets. So this is QQ, meets the condition. Sorry, had to sneeze. So are there 2 quantitative variables right here? And the answer is yes. Both variables, x and y, are quantitative, hence we get a scatter plot. See, watch what happens if I try to do a scatter plot, and let's just say we select these. I don't know. It's not going to it's not going to be like a real scatter plot. I don't know what's going to happen, and look, it doesn't even work. So is it 2 quantitative variables? The next condition is straight enough, which means a straight line. Thank you, Megan. A straight line well approximates the relationship. And the last condition is no outliers, because outliers can do anything to the data. I'm going to look at my calendar. I just feel like my phone kept buzzing. Good. I don't have anything till tomorrow. Okay. Just got to do work tonight. Here we are. Harmonic Sable, Amazing Snail, and Power Gnu, and Vivid Camel, and Decisive Line. Good work. What % of track runners are expected to make a 290 or higher on this graphic? So the first thing you want to do is identify where 290 is at. So I'll work through this right here. So if you're wondering how we solve this, we're going to show how to solve this. On the test, there will be questions that say, use the 68, 95, 99.7 rule. You will get these numbers. So here is one of my biggest tips. When the test starts, draw it out. Draw it out. Did everyone hear that? What am I saying? Draw it out. What am I saying? Draw it out. The code's at the bottom. Oh, the code's at the bottom of the screen. Good to see you there, Billy. Code's at the bottom of the screen. What are we going to draw out when the test starts? We'll do it here in a second. We'll see how easy these are to solve when we draw it out. So, what are we going to draw out? What are we drawing? Who can say in the chat? Great job. A lot of people got this. They probably drew it out. What are we drawing out at the start of the test? And we're going to do it right now. Right here, right now. Right here, right now. We're going to draw the what? What are we drawing out? What are we going to draw? What are we going to draw out? As our computer just goes crazy. What are we drawing out? Who knows? I need your help. Yes, Grace said it right there. Orientation. Go this way. So we're going to draw out the 68, 95, 90. And be careful. And Grace, I'm so glad you said that. Don't worry. A lot of people make a small error. What I want you to do when the test starts is I want you to do this right here. I want someone to write down these steps. When the test starts, find the question that gives you the numbers. Did everyone hear this? When the test starts, step 1 is to do what? Just repeat this because people make errors on this. Step 1 when the test starts is to do what? This is Brian's pro tip for taking the test. Step 1 when the test starts is to do what? Who heard it? Brian's pro tip. You are right, Joshua, but let's say you make an error. I want you to what, though? Just to make sure you get it, even if you know it, like I know it, 68, 95, 99.7. I even know 68.26, 95.449, 99.73. Exactly. I want you to draw it out, but step 1, find the question that gives you the numbers. Does that make sense? Before you start drawing, I want you to look at the question, and this is how the question normally looks. Let's show how the question normally looks. At the top of the question, it'll say, use the 68, 95, 99.7 to solve. It'll probably look, as long as we haven't changed anything too major, it'll look something like this. Does that make sense? So on this question, does that make sense what you'll be using? Like the question will look like that. Find those numbers and make sure you're using the 68, 95, 99.7. Once you have those numbers, draw it out. So let's talk about it. So here's how you draw it. First, draw the normal curve and put how many standard deviations below it. Draw the normal curve and put how many standard deviations above and below 0. Draw the normal curve and put how many standard deviations above and below 0. Answer in the chat. 3. Great job, Joshua, right there. 1, 2, 3. 1, 2, 3. So you put positive 1, positive 2, positive 3, negative 1, negative 2, negative 3. Now you get into the 68 is the middle between negative 1 and positive 1. 95 is between negative 2 and positive 2. 99.7 is between negative 3 and 3. The next trick I call the inside-outside trick. Inside-outside trick. As in, if 68% is between, what is total outside? So what you're thinking is, 68% of the data is between here. How much is total outside remaining? Subtract from 100 to find it. 68% between, 32 total. Cut it in half for 16 on either side. And now we have to do our Tony Hawk ride the rails. What do I mean by this? You get your little Tony Hawk guy here. He's got to wear a helmet. Wear your helmet. There you go. He's got a helmet. Okay, so Tony Hawk guy, and he goes, whee! And if he rides the rails, what should it add up to? If he rides the rails, 16 plus 68 plus 16 equals what? Tony Hawk rides the rails and gets what percent of the curve done? You have to go across. You got to go, jump it, ollie. Wait, you do a little flip. Wait. Very important. Rotate. Look at that. Oh my gosh, we did it. There you go, 100%. Cool. Okay, we'll put them down here. Okay, you can be used again here in a moment. Okay. Best animations here at Stat 201. How much total is outside of 95? How much total is outside of 95? Total outside of 95 is what? It shouldn't get too mad. We always, if there is a flag, we review it. His name should be Terry. Terry Hawk. How much is total outside of 95? Total outside. Total outside. 95 inside? Total outside is what? 5. Cut it in half for 2.5. Now, ride the rails again and make sure. Whoa, cool. There we go. 100%. Make sure when you ride it, 100%. You can go away now. And with this in mind, last but not least, total outside here is 0.3, leaving 0.15. Cut it in half because it's 0.3 and 0.15. There we go. Great work and good practice. So now we do the big arrow, little arrow trick. So that was the inside-outside trick. This is called the big arrow, little arrow trick. As in, you take the big arrow and you subtract from it the little arrow. So you're going to get the area between by doing big arrow, little arrow trick. And so the first thing we can see is that the amount of area here is 0.15, and that is the amount of area below there, below -3. So how much area is between -2 and -3, as in we're talking about this area right here? How much area is between there? What is that area? It's not 2.5 because 2.5 is this. So think we don't want that last portion. Yes, you just subtract off that 0.15 because you're saying, well, that's 0.15. Let's take it off from the 2.5. And so the answer is 2.35. Now you do big arrow, small arrow trick right here to get this one. So you want to get this area here, but you want to take away this area right here. So how much area is that area when we subtract off the 2.5? 13.5. Yep. And then last but not least, this one's actually easier because you can do a trick. It's not, think about what we do to 68 to get this answer. And I drew it pretty well. It's not perfect. I try to go. What do you do to 68 to get this right here, to get this area? Take 68 and cut it in half, and that leaves 34. And now due to the symmetry, you can just go here and do this. Because when it's symmetric, you can just add the numbers. Now we do the percentages. Say it with me, who knows it. Percentages is the amount of area what to a point. Like if you scored in the 98th percentile on the test, percentile means amount of people what to you. If you are at the 98th percentile, and that's a hint for the test, it means the amount below. So when we do percentile, you're literally just looking at the below. So this is the 0.15 percentile, as in the amount of data below this point. The next point using the empirical rule numbers is the 2.5 percentile. Then the 16th percentile, and you can just go up here and see the answer because 16% is below this point. And then here at the middle, you're at the 50th. And then how in the world would I get the next one? So what is the area? There's two ways to get it that are pretty quick. You can think of this, it's not the 16th, or you could think doing this. What is a way to get the next percentile on the curve? The next percentile can be obtained how exactly Megan has it. Just add the 34 right here, or you can subtract from 100 that. There's so many ways. You can just add these numbers as you go across. As you see 34, you can just add and get 50 there. So this is 84, the 84th percentile, the 97.5th percentile, just add that, and the 99.85th percentile right there. So now you have you can't bring this to the test, but you can draw it out when the test starts, and that'll answer a lot of questions. So good practice right here. Let's do the next question. Here we go. Okay. Harmonic Sable, and I will say this, the normal curve is very important for the remainder of the semester. It's used a lot throughout testing and confidence intervals. What percent of area on the graph is shaded according to the empirical rule? Who's got it? And how'd you get it really quick? Who has some answers? There's so many ways to get this. There's so many ways to get this one really quick. There's so many ways. What is your way of getting? We can come up with like 4 really quick ways to get it. If you look at your numbers on the curve, yeah, just take the, I like that. Just take this as 50 and then subtract off the 2.5 right there. Yes, Megan's like, wait, I'm not going to say it till the end. So that's one way. Or you could do this. We could do that. What's another way right here? What's another way? What's another way right there? So I'm drawing it visually for you to see. What's another way? Cut 95 in half, exactly. Great job, Brooklyn, right there. So a lot of ways to get this one. And just think of a test question that could be this. It could be like the scores on the test are a mean of 70. So, finish this test question. The test had a score of a mean of 70 and a standard deviation of 10. And then the answer would be this visually. So the answer would be this visually. So what would be the question that would lead to this from a question that says test scores were normally distributed with a mean of 70 and a standard deviation of 10. So then what would be the question that would lead to this being the answer? It'd be like what percent of students, and then, yeah. So what would be the question then? This is like a reverse, like you have to figure out the question that leads to the answer. Scott, I know someone will get it. It's like, because now you have to think, well, how do we use that information? Like the mean of 70, the standard deviation of 10. If this was the answer to the question, it'd be what? What percent of students? Who's got it? I still have the poll up from earlier. What percent of students what? Between 70, exactly. Nice job. Yep. Between 70 and 90, because 70 would be there and 90 would be there. Yep. What percent of students? Great job, Brooklyn, everyone. So what percent of students score between 70 and 90? Exactly. Okay, let's do the next question. Harmonic Stable still in the lead. Here we go. A Stat 1 test is normally distributed with a mean of 75 and a standard deviation of 5. What percent of students make above a 70? No graphic given to you here. So the reason I did this right here is I want you to look at your drawing. It's easier when you draw it out. It's easier when you draw it out. We're going to go look at the drawing here in a moment. And if you have your drawing, here's what you do. The first thing to do with any of these is to mark your notation.
Notation, brother.
So the notation on this question would be mean is mu, standard deviation is sigma, observation is 70. So now we start our drawing, and at the center of the curve, we put the mean of 75, and then we go down 1 standard deviation. I liked you go down 1 standard deviation and write the number according to it. I like to also put the z-scores below it. Then we're also going to draw what we want to see, the percent of students above. So it has to be a bigger number, right? This would give you the answer if you look at it. You'd be like, well, it's not as big as 95, and it's not like 68. And the way to get this, if you're looking at your curve, is this would have to be right here, 34, and this is 50, as in above here is 50%, and between here is 34. So it's 84. Did we do pretty good? We did pretty good. And did anyone use their graphic, and was it way easier? Because you just went to your graphic, and on your graphic you drew like this line right here where you landed, and then you just shade above it. And then you can literally add the numbers to get the amount above. So this right here is a lot easier when you have the graphic. Yeah, use your... I bet, Megan, you've got this down really well. Like, I can do these in my head really quickly. And I wish you were, like... I sometimes quiz people in person, and they're just, like, so fast at it. And this is very important for later in the semester when we do things like t-test or z-test or the chi-squared. It'll really help that you know this. It's not like people can't do the later parts, but this is fundamental to what we do later in the semester on hypothesis testing. Memorizing the percentiles is the way to go. 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, 0.15. My phone keeps buzzing. I'm going to see what it is real quick. I just keep feeling buzzing. That's nothing. That's nothing. Okay. Oh, it's one of those fake, like... I get so many things about your personal loan inquiry. No. Did not make a personal loan inquiry. Didn't do that. Stop calling me. Stop all the fake calls. Stop it. Cut it out. That's what I say. No. Stop it. Get help. 68, 95. These numbers are given to you on the test. Stop it. Get some help. They have been trying to reach me about my car's extended warranty. Stop it. Get help. Is it get some help? I thought it was get help. Memeing over here. You gotta... If you ever don't know internet culture to a certain extent, then what are you doing? It's what the world is. I was around when Rickrolls were started. Like, that was like the big thing. Like, you didn't trust anything you opened. Not that it would be like a virus or anything. You'd be like, it's a Rickroll. It's a Rickroll. I recently saw something that said, like, it was like a question. It was like, you turn it upside down and it's a Rickroll because it's like a cave or something, and you look at it and it's like they Rickrolled me because it's like do iPad kid. Oh, I wasn't an iPad kid. I was sterile. Oh, who was? Oh, that's Terrell Rip Vine. Oh yeah, the Vines. That's where the Pauls started. Ay ay ay. Oh my gosh. Okay, next question. Here we go. We're oh wait, we got a more bin. Okay, wait. Everyone, real quick. We know what we do when Brian gets a little too crazy.
Let him cook. Let him cook now. Let him cook. I said let him cook.
It's Morbin time.
With Morbin. We got some food. It's Morbin time. Let's do this. Lightning round. Be very careful. The first one's a tricky one. I mean it. First one. We're going to do 2 fun outros at the end. Stay tuned for some fun outros, Jake. What? Right before lightning round. Everyone explain to Jake. In class, do we have fun and do we learn? As Tyler wants some MySpace back. My dad was buying stuff. My dad was buying furniture off Craigslist like a week ago. I said, Dad, don't use that site. We have a lot of fun. We enjoy ourselves. W class right there. Thank you, Tucker, for being here. And this is right before we do the lightning round. I have 2 theories about how students learn. 1, students have to want to learn. You have to want to be here. And 2, you have to be able to effectively communicate to students. So part of my class is getting you to want to be here. So we have fun. We make it fun. And of course, you're not learning when we're morbing in, or are you? So if you don't want to be here, you won't learn. So I have to get you to want to be here, and then we have to actually do some productive stuff. So let's do something productive. This first one's tricky. Watch out. It goes back to the first stuff we did. Let's see if you get it. And it's also a little teaching to the test moment. An ordinal number is a quantitative variable. Jake, we got you, man. We're here to practice. Take note of this question. You might see it again. An ordinal number is a quantitative variable. Don't worry if you get it wrong. Actually, that's what I've been told, Tyler, and I am patient zero ADD. I've been told that this keeps people like, you get like 10 minutes of work, 2 minutes to zone out, 10 minutes of work, 2 minutes to zone out. You can't work all the time. Now, for those who got it right and put false, why was it false? For those who got it right and put false, why was it false? Why is it false? It is false. And you should definitely take note of this because this is one of those teaching to the test moments. Tell your friends. Ordinal numbers are not nominal. Nominals. Ordinal is categorical. Ordinal is categorical. Jake knew it. Great job, Jake, right there. Don't worry. Ordinal is going to be categories. And once again, I put this in the Kahoot because maybe you might see it again. So take a note, write it down, write this one down. As Brian takes some snacks right here. We'll do 2 of our favorite outros at the end, so stay till the end for some fun outros. And we even have a special guest next class. Swing by next class for the special guest. So this is false because ordinal is categorical. Like you can't add. It's the reason it is. Ordinal is not going to be a quantitative. Ordinal wouldn't be numbers though. Ordinal. What's a good example of an ordinal variable? The classic one I love to use. I'm going to pull it up here again. What is the classic example of Brian's favorite ordinal variable? We'll pull it up here again just to show. Brian's and always have a go-to example. Try to have a go-to example in your head to be like, wait, go-to example, stake preference. Military rank is another one. Freshman, sophomore, junior, senior, is that military rank? Something like that. It's private, sergeant, something. I had a game that used to go through ranks. Thank you for those who give service. Much appreciate it. I just don't know the ranks. Captain. There we go. And so stake preference is a great example of an ordinal categorical variable. Are these numbers, yes or no? Just really quick, and then we're going to do the next question. Is rare a number? Is rare quantitative? Now, I know there's a temperature below that, but is private, specialist, sergeant? Thank you, Tyler, right there. Shout outs. Points in the chat, Tyler. So you can see it's not quantitative. Ordinal is categorical, hence why this is false. Next question. Leaderboard first, Harmonic Sable. Those could be debatable. Because you can those could be debatable and there can be ties, so it wouldn't really be an identifier. The best identifier for a race would be bib number, because it's not how much your bib number is. Bib number for a race is the best identifier for a race. And then place in a race is kind of a I would say it's almost quantitative, because it's like how many people your number minus 1 is how many people finished before you. So you could it quantifies rotowave. It quantifies how many people finished before you. Like I think it's a little quantitative. Show them Mubot. Mubot, give them the next question. We must do what Rotowave says.
Time for next question. Let's do this. Quantitative variables must be numeric. Brian is eating in the background. It is not Mubot. Is it the true that's over my shoulder? Or is it false? Must quantitative variables be real numbers that we can do math on? Yes. Quantitative variables must be real numbers that we can do real math on. I needed this. Didn't want this. I needed this. So quantitative variables must be actual real numbers that we can do math on. If you can't do math on it, like group 1, group 2, it's not...
I was doing my Mubot impression. I do a good impression of Mubot. It's just my Mubot impression. No, Tyler. No, it's just an impression. I can impersonate Brian too. I don't know why, but sometimes he also talks with like a robot. No, I mean, I am Mubot. See?
I am Mubot.
The Mubot is a lie. The cake is a lie. With this in mind, we're both talented. We can do impressions of each other. Best imitation of myself. So everyone got that one. Let's do the next one. We're having a load of fun. Not a lie, Mackenzie. Next question right here. Here we go. A variable that consists of numbers is always quantitative, true or false? Watch Rotowave. Rotowave knows what's up. Rotowave's been around here a long time. Everyone got this one, so I think we're good. If something's numbers, it doesn't have to be quantitative. It can group 1, group 2, social security number, telephone number. Those are not quantities of how much telephone you have. I've got all the telephones. All your base are belong to us. Harmonic Sable in the lead. A bar chart is a good way to visualize an identifier. No toleration for Mubot deniers. We'll make that a quote of the day. So we're having a little bit of fun here at the end. I think my energy is going away. That's why I started to eat this. I started like, Brian, come on, man. Morbin. A little bit of lightning round fun. That is quote 599. If you didn't know, if you're new here, we have quotes of the day. Well, you can swing by. Tyler, we do live streams. Tyler, you can swing by the live stream. And you're always welcome here, Tyler. You can do a quote like that, or you can do a quote like this, and you'll see almost one of the 600 quotes that students have said over the history of this class. Here's all the quotes. And then we'll do the last few questions. But these are all the quotes that students have said over the course of this class that have made this class fun and interesting, that students have joked. Don't trust Beard, Brian. We only speak R, no more English. Ban the question. Does that make me Thanos? Things that have cracked me up. We aren't here to do math. It's sometimes things I say, it's sometimes things they say. We need money content. Hannah Montana. Yeah, so these are all quotes that students have said. You can just pick a random quote. If you do exclamation quote, that's when I shoot Tolerant into space. Yeah. Statistic helps you see that you're doing better than you think. Okay, let's make that. That'll be quote 600. Quote 600 from Tyler. We're finishing up. A little more fun at the end than learning, but did that? I don't know why that did that like that. Quote 600, Tyler. You know I have quote 600, so you can swing by. Andrew knows his quote. Andrew's quote is Andrew Wind is the best. He made that quote. Andrew Wind might swing by one of these days too. There might be a Rotowave code in here. There's a Rotowave level. Okay, let's do the last two questions here. Last two questions. Let's finish up, and then we'll do some fun outros. Oh, gotta do the question. Yeah, we could go try to find. I'll see if you're in here, Rotowave. There's sometimes a good reason to remove outliers. I don't see it, Rotowave. If you remember any part of it, I can search. We have students who have told us they drink 10 days a week. No. Impossible. The reason to remove outliers is because people lie about data. They enter data wrong. The best thing to do is to try to fix the data. You don't remove outliers because you don't like them. You look at the data. You make sure it makes sense. If the outliers are not trustworthy, you can remove them. You only remove outliers if you have reason to remove them, as in you are subsetting them, like an extra zero or something. Like someone's like, I make $1 million. And you're like, wait, you work there and you make $1 million? They're like, no, 100,000. You're like, like first try to fix it. Guess interesting fun fact, Tyler. So first try to fix the data. And if you can't fix it, you go and you remove it. Like if the data is completely untrustworthy, you'd be like, well, we can't trust this data, so let's take it out. Or analyze the data with and without the outlier. Never ignore them. Here's a hint. And let me say this. Outliers always require what attention? Good note to have. Back to teaching to the test. Outliers always require what attention? The kind we always want from our friends. Careful's good. Special attention. Outliers always require, they're needy. They are quite needy. They call our attention to them, and we want to give them special attention. Okay. Oh, we got the leaderboard.
I'm Tiny Brian. I'm here for the leaderboard. Great job. 3rd place. I didn't catch your name. Decisive Line. 2nd place. And in 1st place, we have Harmonic Sable. Email Brian and get those gift cards.
Outliers do require more attention for sure. Roadaway, do you have... You're welcome, Tucker. Does anyone have any outros, or does anyone have any opener? We're going to play some openers here for those who are new. I think I might play Stranger Things, and I might play Smash. So if you're a fan of Stranger... it's 1st through 3rd. Sometimes I expand. It's 1st through 3rd. And then, Louis, if you're like in 5th and no one's contacted me after a while, maybe I could expand it. Well, we're just going 1st through 3rd right now. And we only had like 30 people play, so pretty good odds. Tell your friends. 1st through 3rd right here. You're in 4th. No. If contact me in a week and be like, did 1st through 3rd contact you, Brian? So in a week, be like, hey, did those 1st through 3rds contact you? Don't conspire with 3rd place to be like, wait a week. Wait a week to contact Brian. Please contact me. I'll set a reminder. I'm being serious. Yeah, if in a week you say, hey, Brian, did that 3rd place or 1st through 3rd contact you? Which sometimes people don't. And then also, I will say this. I want to give this one caveat. I give people 1 year to redeem the gift cards, because if you don't redeem it in 1 year, I assume maybe you forgot about it. And I'd say 80 to 90% of people redeem the gift cards, but I do it for mini term. I do it for all the tests. Sometimes I do additional ones. Usually yearly, I give out probably maybe $600 to $700 in gift cards to all the winners. So if you think like 20% don't redeem, then that's $140. So I do it after a year. I do it around Christmas time. 6, 7. I don't know. All the memes. I tell people from my generation, us millennials, I'm like, you got to be in there. What do you think of 6-7 Rotowave? What do you think? It's just most people redeem it. Just when you get the email, redeem it. Exactly. Tyler's like, no, stop, get help. With that in mind, let's do 2 outro videos right here. So we're going to do, and wait, Louis, did you have a question? Brain rot, societal rot. I think, well, we had Chappelle Show, Rick James. We had that kind of stuff growing up when I was a kid. I was older. I was in college. We had Adult Swim, Robot Chicken. I'm trying to think what set the culture when I was in college. The culture when I was in college was probably set a lot by like Adult Swim, Robot Chicken, things like that. ATHF, America's Funniest Home Videos? No, wait, what's that? I should know. Do I not know what that is? Uh-oh. And people were just as annoying. Yeah, it's pretty much been the same. There's been the same. Aqua Teen Hunger. Oh, dude, why? Number 1, Aqua Teen Hunger Force. Meet Wad. Get the money. So, Fry Lock, and I'm all time out here with my... I can almost see it. Yeah, Rick James. Oh, yeah, everyone kept saying that, right? Ren and Stimpy. Do. I actually give some. I do a Ren Stimpy throwback, or I make a reference. I say like, "What is it, man?" I'll do that. I'll be like, "What is it, man?" Or was it? There's the Happy Happy Joy Joy song. That song is crazy. Where it's like Happy the Boondocks classic. Was it Aaron Magruder came up with that show, The Boondocks? Good show. Angry Beavers, Courage the Cowardly Dog. Right? You're saying Courage because Courage the Cowardly Dog. They just came out with a Courage the Cowardly Dog game. Boondocks was really great. Started out as a comic strip. Boondocks was really great. Whatever. If you like these things, watch them. If you don't like them, don't watch them. I should check out that archive. That'd be interesting. Once again, you like it, watch it. You don't like it, don't watch it. It's whatever you want. Yeah, Courage the Cowardly Dog. The game is so entertaining. That's what I saw. I watched. I think I watched Moist Critical play it. I just don't do a lot of Steam, or I don't do a lot of computer gaming. I play like Night Rain. I'm addicted to it. Addicted. I want to post a video. You can go, hey, in Night Rain. And you're just like, hey, you just wave to people. And then this one guy was saying hey to me. And then the other teammate and I both went hey. And it was at the exact moment we're all like, hey. It was, so I post hey. It sounds like the Spider-Man thing to me. Miles Morales was like, hey. If you know, go watch. Who here has seen the first Spider-Man? We got some other comments. The new Invincible. Oh, okay, wait a minute. We should do this. We're going to do something right here to end. But go watch the new Spider-Verse. I'm going to say it. Hot take. Miles Morales, #1 Spider-Man. When he, in the new movie, when he did that thing he wasn't supposed to do, I was, you know what I'm talking about? I'm not going to tell you what it is. You're going to have to watch the new movie that's been out for like 2 years. So no spoilers here. Brian knows about what is that one. I don't know that one. Maybe I do know it. But Andrew Garfield, his best moment is in the new Spider-Man movie. He teared me up a little bit. I'm being serious. When he caught MJ. You remember when he caught MJ, Tucker? We're just chilling out for a moment. And he catches MJ, Zendaya. And he says, like, are you okay? And she looks at him and he's like breaking down. And she's like, are you okay? That was his best moment. It is, but I don't think they did it right. I don't think they did the Gwen Stacy stuff right. Like, I think the ball was fumbled on his arc. Like, his whole thing was the Harry in his verse was nah. He was too cool. Spider-Man's a little cool, but he's like I know you have to reinvent Spider-Man, and I think that's what they've done with Miles, which is so cool because Miles is his own thing. Like, he's like, no, I'm gonna do it my way. Like, Miles is his own thing. He's not a Peter Parker, which is, I think, cool. He's Miles Morales. And then what's the guy's name? Who's the? I don't want to. You know what I'm talking about. What's his name? I can't remember his name. I do like the actress more. Well, I like Kirsten Dunst as the actress of MJ, and they actually had an MJ for that series. There was supposed to be a third one, and there was actually they had leaked things of it. My wife loves Toby the best. Bully Maguire, yeah, Bully Maguire. We don't, yeah, when he's wearing black and he's just like walking through the street. At least that's how a Spider-Man would probably be. Like, he'd be a dorky Venom, you know, like, I mean, that's what I see as Spider-Man. Yeah, and didn't they do the pointing? Didn't they do the Spider-Man point? That was amazing. Miguel, I'm thinking of Miguel. You know what I'm talking about? I don't want to say too much. They did in the lab. That's when they did it. Miguel, dude, when Miguel like grabs that thing, he's like, oh, I gotta be careful, break some stuff around here. Mackenzie, we're talking about Spider-Man Far From Home. No Way Home. No Way Home, I think it is. Spider-Man No Way Home, which I think they're doing this fourth one now. Might be New Dawn or something, or New Day or something like that. Hobie. Oh, Hobie's awesome. I like his not Hobie's glitching, but his art style. Hobie's really cool. Also, Hobie was one of, okay, spoilers. We're just chilling out right now. I'll go to the main screen so we can chill out. Class is over. We'll do some outros here in a moment. But when Hobie said something when things were going down with Miles, spoilers, and Hobie was like, "No, man, I'm out." He's like, "No, it's not cool." Like, Hobie marches to his own drum beat. I'd put Hobie. It might be like Miles' first movie, Peter Parker. I liked overweight, sad about his MJ situation, Peter Parker. Miles' first sad Peter Parker, he had a cool arc, and then like Gwen, grabs him at the end, and then maybe Gwen, and then Hobie, and then there's a lot of others. Hobie be up there, but Gwen did really good. No Gwen, no Spider Gwen, no Spider Gwen. What's wrong with Spider Gwen? Maybe first movie Spider Gwen, second movie Spider Gwen. The next Miles movie is officially releasing next year. Good. Does it have a name yet? Does the next Spider-Verse movie, Miles Morales movie, does it have a name yet? You emailed me, Zariah. Nice job. That's what it is. Good work. Any other thoughts? We'll do outros here in like 2 minutes. You're welcome. Glad you had a great time, Tucker. She's so low on your... Oh, no. But then you've got so many more, and I might not remember all their names. Like, you've got Miguel, the other lady... you've got Nick Cage is pretty good. Spider Noir. You've got Spider Noir. You've got the Spider-Man he saves in the second movie, which I kind of like too. Beyond the Spider-Verse. Yeah, I think I saw that name. Oh, I think I saw that they released that one. That's ringing a bell. There's a whole bunch. The lady on the motorcycle, if I didn't mention her, which I don't know her name. Did they give her? She has a name, right? I mean, they're all gonna have names. And then you've got Mecha Spider-Man, which I think is drawn by Gerard Way of My Chemical Romance, the one who was in the mech suit. She was kind of cool, but a little one note. Like it's cool, but one note-ish. The comedian, what's his name, did the Peter Porker, the Spider Pig, which was okay. Once again, a little one note. The Spider Noir, and it's actually like live action. Oh, Miles. Okay, wait. Miles Morales, like he goes a little okay. Miles 2, actually. Here's where I stand right now, and I'm not kidding. I'm putting Miles 2 at the top, because when he's like, what's he say? He's like, how do you know my father? He says something. He's like, how'd you know about this? And he's like, what are you talking about? And he's like, who are you? And he's like, I'm Miles Morales. And you're like, oh. And here's the thing too, is the last thing I'm gonna say on this. He's got him tied to the punching bag, which he had him tied to. Oh, it's so good. And he's on the ceiling. And you hear, it's so good. And it has the purple, like, because you see the purple and the blue. There's so much imagery to that. Those movies are a masterpiece. And I see more comments. John Maloney, that's the guy who did the Spider Pig. Miles 2, and the range of that voice actor, which I think he's done. Yeah, he was trying to save his dad, because the version of losing his dad versus losing his uncle. But even Uncle Aaron in the first one, he's like, you're the best, like I've seen that scene so many times. And his dad comes across it all and wants to like go after Spider-Man. He's like, oh, people are going after Spider-Man. Like, it is so freaking good. Because that's what they get into the second film. It's so good. And then you've got what's his name? Because he's the Prowler in the Marvel movies. You know what I'm talking about. I just can't think of his name. I see his face. I can think of his song. But he's the Prowler in the live action, because he was in the first. I think he was in the first one. Oh yeah, it's so good. And there's so much to the depth of the movie. So if you haven't seen it, check out the Spider-Verse movies. Also check out Flashpoint Paradox. But DC animation is usually amazing. But once they did Spider-Verse, that set up, like, DC always put the bar high, and then Spider-Verse went that. The guy in the jail, but the live action, yes. What is his name? He's Prowler in the first movie. And then what they meant, he actually mentions Miles. There's a slight nod to Miles Morales in the new Spider-Man verse, as though Donald Glover, that's it, Donald Glover. He nods to, in the first movie, he says something like, my nephew or something. Like, Danny Glover. Donald Glover's his dad, right? Danny Glover, right? There's a nod to Miles Morales. So when we were seeing that in theaters, we're like, oh, that's the Prowler. And he's mentioning, he's related to Miles Morales. Oh, because I'm a huge nerd. And then we get the Spider-Verse movies like 3-4 years later. So check it out. Anyone got any last suggestions? We're going to do outros here. So if you want to see outros, we'll do the Smash Bros. Outro first. And then we'll do Stranger Things outros next. Thank you, everyone, for nice, energizing talk. Let's save the notes on this. So we'll just put, like... we had a lot of fun at the end of the Kahoot. We went, like, 2 hours. We'll go 2:00 3, fun spider talk. Check out Spider-Verse. The Spider-Verse movies. They are the best, in my opinion, the best anime movies. What Donald Glover is standing... Yeah, that's true. When the dad tried... Oh, wait. Oh, in the second movie? Yeah, it's a good scene. That's a good scene. That creates that tension right there. That's a good scene. Yeah, we're with Gwen. That's a really good scene. There's so many good scenes. This is the last thing I'll say. We've blown Tyler's mind. I was like, just like,
Wow.
my favorite scene in the second movie is when Miguel, once again, all these spoilers, Miguel is like telling him he's the anomaly. Like, you're the anomaly. And that's when you find out he wasn't supposed to get bitten by the spider. Like, it wasn't him. That's why, like, total spoilers here. That's why his Peter Parker died. Oh, really? Wait, what? I don't know if Braxton's right or not. We'll find out, Braxton. Thank you, Braxton, right there. Well, maybe that's true. Yeah, that was the best. He's like... And then I do think Gwen's line's... I like Gwen's line, like... I didn't... he's like, did you know? And she's like, I didn't know how to tell you. It's like, yeah, he's the glitch. He is the anomaly. He is the glitch in the system. And when the one who controls the machines, when she decides to save him, when she's like looking, and Miguel comes in, he's like, ooh, God. Anyways, I'm going to go watch Spider-Verse. Okay, here's your outros as promised. Bye for now, everyone. Bye! I want you to be able to know the 5-number summary quickly and easily. As always, least to greatest. Laura, 1,000 points right there. And let's do this.
I found him. What's he doing? I don't know.
The 5-number summary is the following values.
He's talking to someone.
From least to greatest, min, Q1, median, Q3, and the max. Nice answers. If you put the 5-number summary in the chat, you get 1,000 points. Keep these answers coming.
What is it? What happened?